Hey, I am Anurag this side. Today I am going to tell you something we find very relatable as a program. Unwanted dependence on AI for solutions. In the modern my age, I see my friends relying on AI for simple solutions. In most of the programs, they even know most of the logic, but they are stuck at some minute point, some little point, and they are taking the help of AI for it. Now, what AI does is we give a problem to it and it supplies a whole code. We give a problem, they supply a code. This logic part goes missing in there. Now, we can't read 100 lines of code and derive logic from that. That's totally impossible. So today, I'm going to give you one or two examples to show you how to build a logical solution to any problem in your mind first and later translating that into code. Let's go. So let's start with a challenge. We will go step by step and find the logic of this challenge. We will not go into code, not at all. We'll just build the logic in our mind and see the magic happen. The problem is we have to find the largest among three numbers. Now, this is a typical program which is done by the beginners, especially first year and beginning second years. So now we are transferring this problem into real life. Let's make it more interesting. Suppose we have three different bags of different weights and we want to find the heaviest bag. I've even done some experiments. These are not actually bags, but they're closer. So as we know, as a human, I have only two hands and I can pick only two bags at once. So I can compare the weights of two bags at once. Suppose I have bag one and bag two. Now, this one seems heavier. This one is lighter. So I may completely ignore this one. Now, let me take the third bag. This one was previously heavier than that one. But comparing this two, this one seems heavier. So now I will ignore this one. This is the heaviest bag. What did we do? We compared two bags at once. The first two bags we saw. We noted which one is heavier and we ignored the lighter one. Then we picked the third bag. We compared the first bag and the third bag. The third bag was heavier, so we ignored the first bag. Now, what if there was a different situation? Let me bring the bags again. Suppose I compared the first bag and second bag. Previously, the first bag was heavier. Now I changed the weights. The second bag is heavier now. So I ignore the first one. Holding the second one in hand, I pick the third one. Now I see which one is heavier. Oops, the second one is still heavier than the third one. So the third one gets ignored now. The second bag is the heaviest. See, now bringing it to numbers is the same. Just we have to give some if-else conditions when writing the code. Let me tell you how to translate it into code now. Simple logic. It's not total code. I will just tell you the simple logic. You will understand it. So, as per the little experiment with bags I did there, this is the logic we found out. What's the logic? This is not the code. This is just the brainstorm logic that we get it from the experiment. If bag 1, the weight of bag 1 is greater than the weight of bag 2, then we checked, then we picked up the third bag, right? So then we compared the bag 1 to the bag 3. So if bag 1 is still greater than bag 3, then bag 1 is the heaviest. Else, bag 3, the new bag is the heaviest. Now, what if this condition doesn't satisfy? That is, bag 1 is not greater than bag 2. The bag 2 is heavier. So, for that, we compare the bag 2 with the bag 3 and find out if the bag 2 is heavier, then this is the heaviest. And if bag 3 is heavier than bag 2, then bag 3 is the heaviest. So this is how we got the logic of the experiment. Finding the greatest among three numbers is the same. It's totally the same. Just instead of B1, B2, you get to keep variables like A, B, and so on. So that's what I'm trying to tell you guys. Just find the logic. Try to find the logic. Just so dive into code straight. Find the logic, brainstorm it, write the logic in your paper. Then try to write the code. Writing the code is not important. Building the logic is the most important. Moving on to the next experiment. It's not experiment, it's kind of a lecture, I guess. but it's one of the most important aspects of programming. Dry run. Let's go. So guys, what is dry run? While performing or building a logic or while performing any programs, we think of some unforeseen, uncertain situations arising inside the program that may cause the program to go wrong, to give random outputs or outputs we don't want. Runtime errors, logical errors, they mostly happen because of lack of dry running a program. So dry running means thinking of any unforeseen situations that they might happen and taking any preventing actions against them to happen inside our logic. I will give one example through the classic leap year problem. Let's go. So talking about leap years, if somebody, some of my viewers doesn't know what exactly the leap year is and how to calculate what is the leap year. So a leap year is basically a year in which the month of February has 29 days. It comes after every 4 years. So naturally, what logic would come to our mind that in order for a year to be a leap year, the year has to be divisible by 4, right? Now, if we think of any unforeseen situations, there is an exception to it. If the year is a century year, unlike this 2020 and 2000, if the year 2000 is a century, suppose for example the year 1900 or 2100, these are century years. These are obviously divisible by 4. But we came to find out that these are not leap years. Oh, now what happens is, if the year is a century year, we can't just divide it by 4 and find out whether it's a leap year or not. We need to divide it by 400. Now, if we try to divide this by 400, turns out this is not divisible by 4. Same for this. So we find out that both of these years, 1900 and 2100, are not leap years. Whereas if the year is not a century year, we can just find it out by dividing it by 4. If it is divisible by 4, it is leap year. In case of century year, the problem arises. Now we wouldn't find that out if we didn't dry run the logic in our mind. We give the code to an AI, the AI will give the correct code. But how do we know whether the code is correct? How do we know that how the AI got into it? By performing this. This putting values inside variables in our mind and finding whether the program works is dry running. This process itself is called dry running. So now if we try to transform this to code, that is a bit of simple logic in our mind. What would we get? Let's see. So guys, as per our problem for the leap year, this is the logic we developed. If the year is divisible by 4, obviously it's a leap year. For example, 2024. 2024 is divisible by 4, it's a leap year. But there is also another condition associated with it, that the year should not be a century year. For example, 2100. 2100 is divisible by 4, but it's a century year, so it's not a leap year. That's why this condition and this condition are ANDed together. Both of these conditions have to satisfy to consider a year a leap year, which is divisible by 4 but not divisible by 100. Then we check if it is divisible by 400. 1900. 1900 is divisible by 4, but it is also divisible by 100. But our condition is that the year should not be divisible by 100. But 2100 or 1900 is divisible by 100. That's why we go to the next condition, which is odd division. We divide the year, for example, 2100 by 400, and we find out that it is not divisible. So the year now can't be considered as an leap year. Now, considering the year 2000, 2000 is divisible by 4, but it is also divisible by 100. If, as we see, it is divisible by 100, so this condition will result false. So now we have to check this condition, whether 2000 is divisible by 400 or not. Yes, 2000 is divisible by 400. So now it may be considered as a leap year. This is what I am trying to tell you guys. Build the logic first. It may be difficult. I also fumbled in this video. The logic building may be difficult, but it is the correct way to get into the code. Don't just straight away dive into the code. Build the logic in your mind and then translate it. I have a challenge for you. Let's see whether you can find it in the most interesting and most amusing way. So the challenge for you is to find whether a number is prime number or not. But this is not as simple as it looks. Suppose you don't have a computer, you don't have machine, you don't know how to do maths. Suppose you live in Stone Age, prehistoric era. Then how would you know whether a number is prime number or not? Just think about it. Think about it and answer me in the comments. I'll see you in the next video.